This video goes with Unit 9, which is States of Matter and Gas Laws. The essential questions are what is the volume of a mole of gas, and how can a volume of gas be converted into the mass? So we're going to talk about how to go from moles to volume, and we're going to measure that in liters, and we're going to talk exclusively about gases. So the molar volume of a gas, you don't have to look on the periodic table, you just have to remember one number, and that's 22.4. That's going to be at STP. STP stands for standard temperature and pressure. So the standard temperature is 0 degrees Celsius. The standard pressure is 1 atmosphere, which is what the air pressure is at sea level. So in those conditions, all you have to remember is 1 mole is 22.4 liters. So let's go ahead and look at how we can use that in some dimensional analysis. What is the volume in liters of 0.4 moles of carbon dioxide gas at STP? So 0.4 moles is my known. I'm going to set up my tracks. I need moles to go on the bottom so it cancels, and I'm looking for liters, so it's going to go on top. I know that every time I'm going to have 1 mole for 22.4 liters. My moles cancel. I'm going to multiply across the top, across the bottom, and divide, and I get 9 liters. So let's look at another problem. How many moles of helium are in a helium balloon that has a volume of 6.5 liters at STP? 6.5 liters is my known. I'm going to set up my tracks. I'm going to put liters on the bottom, moles on top to get those liters to cancel, and it's 22.4 liters to 1 mole. My liters cancel, and I'm going to multiply across the top and across the bottom and then divide, and I get 0.29 moles. Let's look at one more. What is the volume in milliliters of 0.085 moles of O2 gas at STP? So there we're canceling. I've got 0.085 moles is my known. Okay, I've got moles on the bottom and liters on top, and that's 22.4, but it's asking for milliliters. So I'm going to have to continue my tracks, put liters on the bottom and milliliters on top, and I know that for every liter there's 1,000 milliliters, and my liters are going to cancel. So now I'm where I want to be. I can multiply across the top, multiply across the bottom, and divide, and I get 1,900 milliliters. So now we can look at combination problems where we're going for more than one thing. So what is the mass of 60 liters of hydrogen gas H2 at STP? So I'm going to start with 60 liters, that's my known. I need liters on the bottom, and I cannot go directly to grams, I have to go to moles first. So moles go on the top, and I'm going to use that 22.4 number for 1 mole. I'm going to continue my tracks after my liters cancel out here. Now I need moles on the bottom because I want to go to mass, and mass is measured in grams. So I'm going to have 1 mole, and I need to add up the grams off the periodic table. So H weighs 1, the mass has a mass of 1, and there are 2 H's, so it's going to be 2 grams. Moles are going to cancel. I multiply across the top and multiply across the bottom, and then I'm going to divide, and I'm going to get my answer, which is 5.4 grams. Okay, how many liters are in 28.5 grams of neon? So I got 28.5 grams as my known. I need to look up neon. Okay, I've got grams on the bottom to cancel, and remember grams we look up. So grams on the periodic table for neon, it's just by itself, it's Ne, so it's 20.2 grams, and grams cancel. But I want to get to liters, not to moles, so I have to continue my tracks. I need to put moles on the bottom and liters on top, and my liters number is 22.4. My moles cancel, so now I'm where I want to be. I multiply across the top, multiply across the bottom, and then divide, and I'm going to get 31.6 liters. Let's look at another one. Calculate the volume of 8.2 times 10 to the 23rd molecules of methane gas, CH4, at STP. So I start with my known, with my molecules, and my magical molecules number was that 6.02 times 10 to the 23rd, and my molecules cancel out there, but I don't want moles, I want volume, and volume is measured in liters. So I'm going to use my 22.4, my moles cancel out, and now I'm where I want to be. I need to multiply across the top, multiply across the bottom, and then divide it out. And I'm going to get 31 liters. Okay, one more problem here. Calculate the volume in liters of 15 grams of nitrous oxide gas, N2O, at STP. So I start with my known, which is 15 grams, and I need grams on the bottom. I look up my grams on the periodic table, and I have to add up 2 N's and an O for N2O, and I get 44 grams. My grams cancel. I want to be in liters, though, so I need to keep going. I got moles on the bottom, liters on top, 1 mole, 22.4 liters. Moles cancel. I'm going to multiply across the top and multiply across the bottom and then divide it out, and I get 7.64 liters.